Okay, for the moment we've all been waiting for, the rules, the shortcuts. How have I been doing them so fast when y'all have had to work them all the way out? Well, here they are. Rule number 1, the derivative of a constant is 0. Okay, which should make sense since if you think about like y equals 5, say it's right here, the slope is always 0, and because the slope is the derivative, it's 0. So example 1, let f of x equal 5, find f prime of x. Well, it's 0. Yay. So if you just have a number, remember the slope is 0. And now for the power rule. It says if n is any number, then the derivative of x to the n is n times x to the n minus 1, provided x to the n minus 1 exists. In other words, if you had x to the third, you take the 3, you move it to the front, 3, and then you subtract 1 from the exponent. You'd have 3x squared. If it was x to the 5th, you'd move the 5 to the front, subtract 1 from the exponent, 5x to the 4th. If it was 2x to the 7th, you'd do 7 times 2 is 14, subtract 1 from the 7, and get x to the 6th. Let's see. We'll skip over your book does this. Alright, so I just did that one. Huh, just kidding. It says if f of x is x to the 5th, well, it'd be 5x to the 4th. I just did that. Now, example 3, the trick is to rewrite that as an exponent. You know that that's the same as x to the 2/3. Move the 2/3 to the front, x to the, and now you have to do 2/3 minus 1. 2/3 minus 3/3 is negative 1/3. So it'd be 2/3 x to the negative 1/3. Or sometimes you'll see that written 2 over 3. Remember, negative exponents can move down, x to the 1/3. Or you may even see it written like that. Those are the same. So that's the derivative, f prime of x. Let f of x equals 1 over x to the 4th. The trick is just to rewrite it, and then you can use your power rule. As f of x is now x to the negative 4, so your derivative, move the negative 4 to the front, x to the negative 5, because negative 4 minus 1 is negative 5. And you can rewrite that just like that. The constant multiple rule. It's the exact same. You just, if there's a number already in the front, you just multiply it. 7 times 5 is 35, x to the 6th. Subtract 1 from your exponent. I'm going to rewrite this as 4/5 x to the negative 3. Multiply negative 3 times 4/5. And remember fractions, negative 3 times 4/5 will be negative 12/5. X to the negative 3 minus 1 is negative 4. Oh man. Nope, I didn't break my stylus. I almost did. Negative 12 over 5x to the 4 is the derivative, f prime. Or in this case, it would be g. I know. It's g. And in this one, it says to call it dy dx. So dy dx equals. Keeping going. The sum and difference rule, if you have more than one little monomial, if you now have a polynomial, you just take the derivative of each individual term, no problem. Derivative of x cubed is 3x squared plus 2 times 4 is 8x minus 2. And that's y prime. I'm going to rewrite these. This is going to be 3 over negative 2 to the 4th is 16x to the 4th minus x over 2 plus 1/4. I'm going to rewrite it one more time. Oh, by the way, remember that the derivative of this constant term, 7 here, was 0. Let's see. That's 3/16 x to the negative 4 minus 1/2 x plus 1/4. So, my derivative would be, I take the negative 4, multiply it by 3/16, that's going to be negative 12/16 subtract 1 from my exponent, x to the negative 5, minus, remember the 1/2 x has an exponent of 1. 1 times a half is a half. 1 minus 1 is 0, so it's x to the 0, and remember x to the 0 goes away. It just occurred to me that I may not have elaborated on that here. Anytime you have like something like 5x, the derivative is just 5, because think about it, that's a line, like mx plus b. What's the slope of that line? The 5. So anytime you have one that just has an x of 1, it just goes away. And then plus 1/4, the derivative of that is 0. So it would be plus 0 if you wanted to write it out. Okay. This one says find the equation of the tangent line to the function. When you see tangent line, immediately you should say y equals blank, x minus blank, plus blank, and start filling stuff in. X is 2. Y, to get my y value, I fill it back in up here. 4 times 2 cubed minus 6 times 2 plus 5. 2 cubed is 8 times 4 is 32 minus 12 plus 5. 32 minus 12 is 20 plus 5 and 25. And y'all be looking for mistakes in these because I'm in here by myself, so there's no one to correct me. And y'all know how I do. Now, the m is going to be my f prime. That's my derivative, my slope. Because remember, when you find derivative, it's just the slope. So I need to find f prime of x. And I go up here. 3 times 4 is 12. X squared minus 1, the derivative of 6x is just 6, so minus 6. So now I fill in my 2, so 12 times 2 squared minus 6. 2 squared is 4 times 12 is 48, minus 6 is 42. That feels awful big. I hope that's right. Double check me. There's a possibility that I made a mistake right there. 42 just seems... I'm going to check myself, just because I'm not sure about that. Remember how to check yourself to check your derivative. I'm going to add a calculator. I'm going to go menu, calculus, derivative at a point. My point is 2, and 4x cubed minus 6x plus 5. 4x cubed minus 6x plus 5. Okay, well, I was right. Yay, I was right. It says find h prime of x. Well, the first thing we're going to do is we're going to multiply that out. We're going to fold it. That'll be 2x to the third. My necklace is making noise. Minus 5x squared plus 2x minus 5. I'm checking myself. Yeah, that's right. And this is h of x, so now I do h prime of x. So that's 3 times 2 is 6x, subtract 1 is squared, minus 2 times 5 is 10x, plus the derivative of 2x is just 2, the derivative of negative 5 is 0, so there's my derivative. The volume of a cube with sides of length s is given by v equals s cubed. Find dv ds. That just means to find the derivative of v with respect to s. That is all that means. So dv ds is just, I multiply the number to the front, 3s squared. And since when s is 4, that means I fill in a 4. dv ds of 4 is 3 times 4 squared. 4 squared is 16 times 3, I don't know, 48, I guess. Centimeters, and per, it doesn't give us a per, does it? Cubes. Find the derivative of the volume with respect to the side. Yeah, it's just centimeters. I'm not sure about the unit. We'll come back to that, because it didn't give us enough information. It should have gave us more. Okay. It says, using Rule 4, we know that the derivative of the sum of two functions is the sum of the derivatives of the two functions. In other words, if you had x squared plus 3x. It's just the derivative of 2. It'd be 2x plus 3. You can take the derivative of each one individually. You cannot do that when you're multiplying. If we multiply x squared times 3x out, we get 3x cubed. If we then take the derivative of that, 3 times 3 is 9x squared. Now let's try to do it individually and see what happens. If we took the derivative of x squared, it'd be 2x times 3, which is 6x. So did it give me my answer? No, it did not. We cannot take the derivative of multiplication of product and quotient. There are rules. The first one we're going to look at is the product rule. And I say it's like this, just to help you remember it. 1d2 plus 2d1. It's just a little, it's not really a rhyme even. 1d2 plus 2d1. There's nothing. It's just a way to remember it. 1d2 plus 2d1. What that means is, if I'm looking at this one, first use without using the product rule, then with the product rule. No, we're just going to use the product rule. Okay, this is like my 1, and this is my 2. And to help me out later, I'm going to go ahead and write that as to the 1/2 times 5x cubed minus 7. Okay. I'm going to do 1. In other words, I just write it as it is. Times d2, that means times the derivative of the second, so that's 15x squared. So 1d2 plus 2, write it as it is, don't change it, d1, the derivative of the second. 1/2 times 2 is just 1x, 1/2 minus 1 is negative 1/2. So 1d2 plus 2d1. And I can leave it like that. I don't have to simplify it. It's perfectly okay just to leave it. Sometimes it helps to simplify it, but remember that if your answer is correct, it's correct, period. This is perfectly fine. I do not have to keep going. Quotient rule. He does ho-de-hi. I don't like that. We say low d-high minus high d-low over the square of what's below. Low d-high minus high d-low over the square of what's below. Prepare yourself. Okay, low. That means this is the high and this is the low. Anytime you have a quotient, you have two things divided, this is what you do. Low, x squared plus 1. D-high, the derivative of the top is just 1. Low d-high minus high, the top. D-low, the derivative of the bottom, over the square of what's below. X squared plus 1 squared. You can leave that. Don't try to mess with it. If you really want to, you could say x squared plus 1 minus 2x squared over x squared plus 1 squared, or negative x squared plus 1 over x squared plus 1 squared. Unless I made a mistake, which is possible. So low d-high minus high d-low over the square of what's below. Alright, so let's do another one with the quotient rule. And if you want to pause me and try to work it yourself and then check yourself and see if you're right, that would not be a bad idea. So pause me. Okay, turn me back on. Alright, low, x cubed plus 1, d-high, 10x, minus high, 5x squared, d-low, 3x squared. Low, I'm checking myself. Low, d-high, minus high, d-low, over the square of what's below. X cubed plus 1 squared. We should be almost done. Oh, nope, just kidding. Okay. You can take the derivative again. The second derivative is defined as the derivative of the first derivative. The third derivative is the derivative of the second derivative. The fourth derivative is the derivative of the third derivative, and so on and so forth forever and ever. Amen. So it says find the fourth derivative of this. So we're going to start out finding the first derivative. And I'm just going to call it y prime. So 8 times negative, oh, this is going to get big. 8 times negative 5 is negative 40, x to the 7th, plus 12, x to the 5th, minus 3 times 9 is 27, x squared plus 32. That's the first derivative. The second derivative is, let me pull my calculator out, 7 times 40, I know I should be able to do this by hand, but I don't want to mess that up. Ah, hit clear. 7 times 40, 280. So negative 280, x to the 6th, plus 12 times 5, I know, is 60, x to the 4th, minus 2 times 27 is 50-something, 54, x. And then y triple prime, 6 times 280, what? 1680, negative 1680, x to the 5th, plus 4 times 60 is 240, x to the 3rd minus 54. And then y4, and you just put it in parentheses right there. You don't have to keep doing primes. 5 times negative 1680. Really? Negative 8400, x to the 4th, plus 3 times, again, 240, 720, x squared. And that is my fourth derivative. And here, just as a quick, let's see, is it going to say do it on the calculator next? No. Okay, I'm just going to really show you how to, well, I'll tell you what, we'll save the calculator till tomorrow. I'll show that in class. I don't want this video to get too long. I feel like it's getting kind of long now. This one says find the f double prime of x. First thing I need to do is find f prime of x. And this is a quotient rule, f prime. So low, d high, minus high, d low, over the square of what's below. Now, if you're going to take the derivative again, it is best to simplify it first. So we have, that's x minus 1 minus x. So it's really just negative 1, because the x's cancel, over x minus 1 squared. Now I'm going to take the derivative of that. So it's low, d high, the derivative of negative 1 is just 0, minus high, d low, oh, crud. You don't know how to do that yet. What in the world? That's the chain rule. Monkeys. Oh, crap. Okay, yeah, we do. We're going to have to full it out. X squared minus 2x plus 1. That's the only way we can do it as of right now. So where was I? Low, d high minus high. D low would be 2x minus 2 over the square of what's below to the 4th. Took me a minute to realize that you don't know what the chain rule is yet, so we have to move on. And then this one, find f5th. If they give you the 4th derivative and they want you to find the 5th derivative, you just take the derivative of the 4th derivative. Rewrite it. Multiply the exponent to the front. 1/2 times 2 is 1. X 1/2 minus 1 is negative 1/2. And that's done. Or I could write it as 1 over the square root of x. And that's it. Stop.